back for day number 2 of Gen Chem. And we're going to be continuing on our way through the first chapter here. And if you remember from last time, we spent quite a bit of time just talking about certain definitions. What's the definition of substance and matter and elements and compounds and all this other kind of stuff, which is this common terminology that's thrown around as we go through the different chapters for this class. Remember, or I can't remember if I talked to you guys about this or not, but one of the challenges that comes with Gen Chem is that math is obviously part of it. I remember talking about that. But it's also, there is this language that goes along with it, right? We have to use this chemical language to describe different reactions and things that can happen, right? And we can calculate certain things along the way with that. So it's kind of like learning a whole new language along the way too. That is going to be one of the challenges that's going to be kind of, let's say, behind the scenes for everybody here. What do I mean with this? What I mean with this is part of the challenge from this class just comes from, can you guys read the information that's coming in one of the word problems or something like that, okay? And so that's why we're spending a lot of time just kind of making sure that we have a strong foundation on the definitions behind the scenes here, okay? Oops, let me get that sidebar out of the way there. Right. We talked about physical properties, we talked about chemical properties, and we went through and we described certain things. We talked about shapes and sizes and mass and all these kind of things. And then we started to get into the idea of, okay, well, what are some physical properties that we can measure? And we're going to talk about how we can measure and use those measurements to figure out certain chemical information throughout this semester, right? That's going to be the goal. Okay, we can measure temperature. Who cares? Well, temperature can tell us certain things about the properties or how the molecules are behaving. That's the kind of stuff that we're going to look at, okay? And then where we ended up, we were talking about kinetic molecular theory, okay? And we defined what that is. When we talk about kinetics is the energy of motion, right? And we're talking about the motion of molecules and all that stuff in there, right? We talked about the important parts of the differences between solids, liquids, and gases. I know that everybody in here can qualitatively understand the difference between solids, liquids, and gases. I get that, but remember we were talking about how do these molecules move around, right? And that's the important part. You know, why does a liquid flow if we tip it out of a pitcher of water or something like that, right? It's because these molecules can flow over each other. And we're going to talk about kind of how we can calculate and get information out of that kind of stuff, okay? Good, so there's our little recap from last time. We're going to continue on. We'll see how far we get in chapter 1 today. We might even get a little bit into chapter 2, just kind of depending on things. So we'll just kind of keep moving along as time permits, right? Thought there was something else. Oh, right, yeah, that's what it was. So this evening at 5 o'clock?
4:50.
4:50?
Yeah.
What happens at 4:50?
Wow.
Oh, no. Maybe. Do you guys have lab this week? Is that what it says in the syllabus? You guys are doing the safety and check-in? Is that what it is? That's what happens. Okay. Yeah. So make sure you guys are going to lab. Thank you. That's a good reminder also. But we're also doing a presentation on the research that we do here at Ave Maria. So if you guys are interested in coming and seeing what the chemistry and physics department is up to in terms of the research that we actually do, there is a link that was sent out yesterday in the email, and there's also little posters that are hanging up. You can just scan that QR code and it'll just sign you up for coming out tonight. Now, why would you guys want to do this? Well, I can't offer you a free t-shirt, right? But I can give you at least free pizza and stuff, okay? So, but we need to know how many people are going to show up so we can feed the people who do come over there. But come take a look at what we're up to around here, and if you guys are interested in doing research at all, if you guys are continuing on in your careers in the sciences, it'd be a good chance to at least learn what's happening around here. And at the very least, you guys will get some free food out of it. Sound good? Well, I'm stuck in the lab, Dr. H, right? That would start at 4:50, right? Right, if you're stuck in lab or if you have other obligations, but you still want to learn about these things, just come talk to me or talk to Dr. Tong or Dr. Barbosa. I'm the least scary out of all 3 of those, so okay. So you can, no, I'm just kidding. So you can come chat with me and say, hey, I couldn't make it. I'd like to learn a little bit more about this. What can I do as a freshman? Or I have never had any experience in lab or any of this kind of stuff. Well, remember, you guys are here at a university, and part of the time at a university is to do what? Learn things, right? So we understand that not everybody has experience working in the lab, but that's also part of why we do what we do around here, okay? So if you're interested in that kind of stuff, just come talk to us or come join the meeting tonight or whatever it might be. Sound good? All righty. Okay, I think that's all I have to say about that. All right, so let's get started with some prayer, and then we will continue on walking through the notes here then. So Lord, we just thank you for another day. And we thank you for an opportunity that we can sit down and just learn about the world around us, the universe around us, Lord, and just how you made that. Lord, we pray and just in thanks that we can learn about creation and the things that you have created around us so that we can turn our eyes to you in these things. Lord, just help open our minds, our eyes, and our ears just to look at you a little bit in a different way and just see the beauty that you've created around us, Lord. We pray that we can just reflect that beauty to anybody else around us who might be interested in hearing about you, Lord. We pray for those opportunities just to share what you've done in our lives with those around us, Lord. Give us the courage to step up when that opportunity happens and give us your words in our lips, Lord. And we pray all this in your name. Amen. All right. So, kinetic molecular theory, solids, liquids, and gases. This is basically key for everything we're going to be talking about. Behind the scenes, this is how things are going to be working, okay? Later on in the semester, when we start to learn about reactions, we're going to talk about collision theory, which I think I talked a little bit about, right? You know, reactions are basically car accidents on the very, very, very small scale. This is the idea of things moving around is going to be extremely important, right? So solids, liquids, and gases. I think this is where we stopped. Is that correct? Yeah. Okay, cool. So a couple of definitions and things and how we start to use some different terms around here. Most substances are compounds, and compounds will decompose into simpler substances, okay? And so if we have something like sugar, right, sucrose, or any kind of disaccharide or any of these complex sugars, they are essentially made from carbon, hydrogen, and oxygen, right? Now, you guys knew that. You guys knew that all sugars were made out of carbon, hydrogen, and oxygen. Sure, right? We've heard this before, and we might have even learned about C6H12O6, you know, these kind of things, right? It's another term for a sugar, though. Begins with a C. Yeah?
Carbohydrate.
A carbohydrate. Now, why in the world would these things be called carbohydrates? Well, it's a complex sounding term, and it sounds cool, right? Is that how science works? Yes, right? We want to be impressive. I want to scare the people around me by using big words, okay? Then they don't ask me hard questions because they think I'm smarter than them. That's not the case, I promise, okay? I'm not smarter than anybody else. I just happen to be good at chemistry. That's the only difference, okay? What's in a name, though, is what I'm trying to get you to think about. Well, gee, what do you mean by carbo and hydrate, maybe? Yeah.
Carbon.
Carbon, well, if we decompose sugars, right, there's going to be some carbon left over. Any of you guys in here like to cook? A couple of you guys maybe? No? Nobody? 2 people. What? That's it? Oh, okay, over here. The rest of you guys are like, I like the microwave mac and cheese. That's where I hang out, right? Right? If you're like me, I do like to cook a lot. I think it just comes with the field of chemistry, right? But I don't like to bake things. I'm not a huge like dessert person, right? I've had too many bad experiences with burning sugar. You guys ever done that when you're cooking? What happens to the pan when you burn the sugar? It gets wrecked, right? This is, you have this black tarry mess in there. You're like, screw this, I'm going to throw this away. You can never get it out of there, right? You're decomposing these things into carbon is what it is, right? Now, that's actually a very important field. Burning sugar, important field. No. What I mean is formation of carbonaceous material is actually extremely important in modern, let's say, science, right? Because carbon has a lot of interesting properties. It can be conductive, right? You guys have maybe heard of like carbon nanotubes and nanowires and things like that. That's just a form of carbon. If you can make that from sugar in your kitchen, then you'll be rich as soon as you patent it, right? That's not quite what happens when you burn it there, right? Carbon can also be used to store different gases and things. I'm sure you guys have heard about how hydrogen, right, is the fuel of the future, these kind of things, right? But what's the problem with hydrogen? Well, it's a gas. How do you store a gas? The answer is not easily, right? We have to be very careful how we store, especially a gas like hydrogen, things like that. But we can absorb or adsorb hydrogen into carbons and things like that, right? So carbon is actually a very, very important compound, which we'll talk a little bit about. Aside from that, we got hydrogen and oxygen. Now, what do you guys know happens when you mix hydrogen and oxygen? You make water, right? So H2O is water. So if I'm telling you that another name for sugars are carbohydrates, should it make sense that I can produce carbon, hydrogen, and oxygen from it? That's exactly what it is.
Now what we're kind of walking through there, we'll come back to in just a little bit, we're going to be talking about empirical formulas of things, okay? So can I boil everything down, to use a bad analogy here because we're talking about water and stuff, right? Can I boil the formula down to the simplest component, okay? C6H12O6, right? 6, 12, and 6. If I divide everything by 6, what do I get? 1, 2, and 1, right? So that's what we're going to be doing when we're talking about, let's say, decomposing or taking things into simpler terms, our empirical formulas, right? So just think about this when we come back to it in just a couple of chapters, okay? A compound is a substance comprised of 2 or more different elements. Remember, that's something we talked about a little bit previously here, okay? Now, where are we going in the future? Well, it's great that we can name something like sucrose and we know what it's comprised of and all these kind of things, but as soon as you move past Gen Chem, and if you guys are moving on to organic, I know a couple of you guys are doing that, we're really going to have to start to pay attention to how things look, okay, the shape of molecules. And so we're going to talk about that in chapters 6 and 7 and 8, okay? Did you know that molecules have shape? Sure, right? How do you know that? I'm made of molecules. Do I have shape? Right? Yes, okay? Where does my shape come from? Well, eating a couple too many donuts sometimes, right? And then shape changes, you get what I mean? Okay? But as you make different molecules, as you're dealing with different molecules, it's very, very important to take a look at how they're actually put together, okay? And that's one of these key fundamental ideas of chemistry. Shape defines function, okay? That's not just me saying that, that's science throughout the years, okay? And so we're going to talk about some of those shapes also. That's what sugar looks like right there, sucrose. And we'll talk about how we know rings form and all that kind of stuff as we go through the world of chemistry here. Okay? All right. So compounds have a specific composition. Sucrose is always going to be blah, 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 blah by mass, right? I don't care about those numbers. We're going to figure out how to calculate those numbers, okay? We're going to talk about empirical mass of different things. We're going to figure out how we can convert percentages into the formulas and formulas back into percentages. That's going to be extremely important for us, okay? So you don't have to write down the exact percentages there, just compounds have specific composition, and we're going to be talking about those compositions. Compounds have specific properties. Now this is something that if you haven't already memorized, at least put it in the books, right? Water always melts at, melts.
32 degrees Celsius.
32 degrees Fahrenheit, but we'll talk about this in just a minute. We don't really deal with Fahrenheit too much in the world of chemistry. Okay, we're going to be dealing with what's known as the SI units, right? So typically when we're talking about temperatures in the sciences, we deal with 2 things, Celsius or Kelvin is what it is, okay? So it's always good to kind of keep that in mind, and we'll talk about when we use the different scales here and why it's important, okay? So 32 degrees Fahrenheit, that's good to know. In Celsius, that would be 0, okay? So 0 degrees Celsius is where water melts. Now we're going to talk about how that's kind of a lie. You guys get what I mean by this? Well, wait a minute. I'm telling you that water melts at 0 degrees Celsius, right? What temperature does water freeze at? You guys get what I mean with this? So remember, it's interesting how I ask you the question here. I'm defining, okay, something is melting, tell me the temperature. I could ask you the exact same question about how something freezes. And there's a change of energy that happens at that temperature. And we're going to talk about that in chapter 5, I believe is what it is, okay? So pay attention to some of these kind of, I hate to use the T word here, tricky. It's not being tricky, it's just paying attention to how the question's worded, right? So water always boils at, and I think we got the answer earlier there, 100 degrees Celsius, right? So freezes at 0, boils at 100. What is it in Fahrenheit though?
212.
212, got it? Is it always 212?
Yeah.
Anybody in here from Colorado? Or higher elevation than we are? So I've got a friend of mine who lives in Denver, okay? And so when I go to visit them in Denver, I'll make up a fake story that sounds like it's real. I do have a friend, that's not the fake part of the story. Right? So let's say that I'm visiting my friend in Denver there, right? And I'm making brownies that come out of a box, right? If you're paying attention, if you ever read this sometimes, on the back of there it says instructions for higher elevations. You guys ever seen that in some of the food that you've made? Some of you guys have, some of you guys haven't. Why do we need different instructions? Well, we've got different pressures, right? As elevation changes, we change pressure. And we actually change the boiling point of water, okay? As you go up in elevation, the boiling point goes down. So the question is, well, what in the world, or how can we define a boiling point then? Okay? And so we're going to talk about how we define boiling points at standard temperatures and pressures, right? And so we're going to have to define, okay, at 1 atmosphere, it will boil at this. But if you're in Denver, you have less than 1 atmosphere, so the boiling point's going to change. And we're going to talk about how to calculate those kind of differences there too, okay? So for our purposes and in general life, right, we can assume that 0 and 100 degrees are going to be our boiling points and melting points for water, though. That's always something good to know, right? Water, we're going to be using a lot in this class. There's going to be a lot of questions that deal with aqueous solutions, right? So keeping this in mind. Let me put it a different way. I'm never going to give you the boiling point of water on an exam, right? I would just expect you guys to know that. Does that make sense? But speaking of things that I give you on the exam, have you guys seen the equation sheet that I uploaded for you guys? Some of you guys have, some of you guys haven't. This is important, because one of the questions that I'm not going to answer for you, okay, is will I have this equation on the exam? Do you know why I'm not going to answer that for you? Because I already answered it for you. I have uploaded, right, the equation sheet that you guys will have for every exam, okay? So take a look at that, do it before we have the first exam. That way you guys don't spend time memorizing something that I give to you, okay? In general, I will give you guys all the equations that you need. Why? Because I want you guys to focus on understanding things, not memorizing an equation. I need you guys to know how to use the equation, not, oh gee, was it a plus or a minus here, and then you forget and the problem goes, you miss the problem. So take a look, I think it's under the modules, under the important course files, right? It says potentially useful information for exams. Take a look at that, please, okay? You notice what else is on there is the periodic table. I'll always give you guys a periodic table. I'm going to expect you guys to memorize that. Why? You guys have better things to do, okay? Right? So you'll have the periodic table there. Use it. Take a look at that file before the first exam and those kind of things, okay? But I'm not going to give you information about water boiling and that kind of stuff. All right. Elements cannot be decomposed into 2 substances, okay? This is something important. So when we talk about the periodic table, what is really the name for the periodic? Oh, did you find the sheet or something on there?
No.
You were showing them a funny video?
No,
No, just kidding.
I was just trying to get it.
Oh no, it's all good. I'm just picking on you, right? So what is the actual name for the periodic table? It's not just periodic table, it's periodic table of the elements. Got it? So we're going to be dealing with chemistry. I'm glad you guys are sitting down because I'm going to give you a shocking statement. You ready? We're going to be talking about the elements. I know. A stunned silence from the audience. They were shocked. Now we're going to spend a lot of time with the periodic table. And I don't say this with too much hyperbole, that being able to read and get information out of the periodic table is one of the key things that you guys are going to need, not only for this class, but also when you guys go on to organic or biochemistry or any other chemistry class that you guys take, okay? There's a lot of information in there aside from just, oh, where is carbon? It is here, okay? So we're gonna talk a lot about how we can look at the different elements and what information you can get out of that from the periodic table there, okay? All right, so now that we've talked about a bunch of different things, let's talk about some other important things here to recognize. So units of measurement. So obviously we're going to be dealing with things like temperatures and pressures and boiling points and melting points and amount of substances, how much energy there is, how much voltages are exchanged, or what's the potential for something. There's a lot of different values with a lot of different units that we are going to be discussing and learning how to manipulate in this class, okay? A couple of important things to recognize. When you guys report a number to me, on an exam or a quiz or something like that, always make sure, okay, that you guys have a unit with that number. Does that make sense? 11. 11 what? 11 apples? That sounds good. I'm hungry, right? I haven't eaten lunch yet. Okay? 11 points on an exam out of 100? Ugh, not so good, right? Being able to define what a number means is going to be extremely important. So always, always, always put your units with whatever numbers that you guys are calculating. Does that make sense? I'm not just doing this for fun and that, you guys need to spend calories writing, a temperature or something like that. This is one of these things that's gonna help you guys solve the problems. Are a lot of you guys taking physics too? Or I don't mean like the second class, but physics as well? Any of you guys, physics, some of you, right? This is gonna help you out when you guys are taking physics, okay? Because physics is basically just like what we're gonna do in here. You guys are gonna be changing numbers around, calculating different things. Keeping track of your units is gonna help you guys out. It's gonna prevent you guys from flipping denominators and numerators around and calculating the wrong thing along the way. Okay, so get in the habit of writing out the units, and you'll see when I start working through problems with you guys, that's what I do also, okay? I'll go ahead and share with you guys now. Math is not my strong point, okay? When I was sitting down where you guys were, right, not that many years ago, math was not something I felt all that comfortable with, especially when I came to Gen Chem. You know what the secret is? I've just been doing this for a long time now, right? So now I'm a little bit more comfortable with it. It's just like practice. But one of the things that I didn't listen to my professor, and I know exactly who she was, okay? I know exactly who taught me Gen Chem. She still teaches there where I went to undergrad, okay? But she told me this exact same thing. You know what I said? Okay? That's for somebody else. Years later, I'm like, crud, she was right, okay? So, same thing I'm gonna tell you guys here, and I'm going to be looking at this when you guys, give me your answers on exams and things like that. Sound good? Okay, so what units do we have? Units of measurement. If we're dealing with length, the SI unit for that is going to be a meter, okay? Lowercase m for that. If we're dealing with mass, measuring something, it's actually a kilogram that we technically have as our SI unit, okay? Now, we're gonna be dealing with mostly, right, with grams of things. When you guys are in the lab and you have to measure something out, very rarely will you have to measure out a kilogram of anything, right? How much does a kilogram weigh in pounds of? Anybody know? About 2.2 pounds for every kilogram, right? Why do I tell you guys that? Well, remember, I'm teaching you guys maybe some new measurement systems here. If I tell you I have 5 kilograms of gold in front of me, you're like, I don't know what a kilogram is, right? Is that a lot? Is that a little? Right? But if I tell you 10 pounds of gold, just doesn't, right? Then you're like, oh, okay, that's something that we're more familiar with, okay? So something to keep in mind when you guys are working through these problems also. That's why we're talking about Fahrenheit and Celsius with the boiling point of water there too, right? Give you guys some context for the answers that we're coming up with. Temperature in Kelvin. Now wait a minute, I just told you that the Celsius is typically what we're gonna be dealing with. That is or is not the case, right? What I'm saying is technically Kelvin is what we should be using, right? But Celsius is kind of where we stick around most of the time until we get to chapter 10. And then we'll almost exclusively be using Kelvin. And we'll talk about why that is as we go through it, okay? So Celsius and Kelvin both are fine. I don't care which answer you guys give it in unless I define, say, hey, tell me the temperature in Celsius. Then I want you to report the answer in Celsius. But if you guys want to work in Kelvin, that's fine too, okay? Time in seconds. Amount of substance, how much of things. Now this is going to be one of the biggest stumbling blocks to begin with. And we're going to spend a lot of time on dealing with what a mole is, okay? So we're going to spend a lot of time dealing with what a mole is. It's one of these fundamental things that we calculate in Gen Chem. Why do I keep telling you things that are fundamental? That means you're going to have to do it over and over and over and over and over and over and over again, okay? So we have to be comfortable being able to report what a mole is. Electric current in amps, we'll do pretty much all of that in the second semester of Gen Chem. We'll calculate how current is generated, and I think in one of the labs you guys even kind of build your own battery, so to speak. Not using a potato, don't worry, using different solutions and stuff. Luminous intensity, we really don't talk too much about calculating intensity, although we do talk about light quite a bit when we get to chapter 6 though, okay? The other end of this is scale, all right? So I can define things as a kilogram. What if I have 1,000,000 kilograms of something? Well, I don't want to sit there and write out 1, 0, 0, 0, 0, 0, right? So we're going to be talking about scientific notation, okay? And we're going to have to be able to convert between things like kilogram, right, and milligram. So these are things that you guys and I expect you to memorize, okay? So for what it's worth, I'll give you guys let's say a cutoff point here. Let me do this. So up to the 12s, right, is what I expect you guys to kind of know, right? So if I give you units of deca something, that should mean something to you guys. right? If I give you centi, milli, micro, nano, pico, right? That should be something that you guys are familiar with. But the other ones are on there because that's the complete list, but that's not something you need to know, okay? Sound good? Now some of these guys you might be already familiar with, okay? That's okay. But this is information that will be on the first exam. I can guarantee you at least 2 questions on the first exam, probably more, will be convert 100 milligrams into 100 centigrams, or excuse me, 100 milligrams into centigrams. And you guys will be expected to do that conversion using these values here. Now we're going to go through some examples with this, okay? I'm not just going to throw you in the deep end without showing you, but I do need you guys to know that. Sound good? Everybody with me on that? All right. All right, let's talk a bit about volume. Okay, so volume is not a base unit in SI there, right? What we were just talking about, the Système International, right? That's what the SI means, like international system. But volume is something that we use quite a bit as we go through Gen Chem. We're going to be talking about how much of a liquid is produced. Or I need you guys to measure out 5 milliliters of something, right? These are all units of volume. Okay. Now, if you're looking down here on the screen here, right? Maybe you guys have heard about cubic centimeters or cc's, right? If you guys watching TV and are watching one of those like medical shows, I need 30 cc's of blah blah blah, right? You guys ever heard that? Right. So this is what we're just talking about. A cc is a cubic centimeter. Okay. So if we're talking about, if you imagine a centimeter, right, and you make a little cube out of it. It makes a volume of exactly 1 milliliter, okay? So 1 milliliter in cubic centimeters, these are equivalent values. You guys with me on that? Volume is a measurement, right, of 3-dimensional space. You guys follow what I mean with this? Right, how much space does something take up? Right? I believe this is one of the first labs you guys are going to be doing, looking at densities and measuring these kind of things, and volume is going to be something that you guys are doing with that, okay? So it's a measure of 3-dimensional space. Now, why do we care, or why do I make the point that this is 3-dimensional space? Well, take a look at the units that I'm reporting for you guys here. Centimeters to the 3rd power, cubed, right? What does that mean? It means I have centimeter, and centimeter, and centimeter, right? Length, width, and height, right? Those are our 3 dimensions. You guys following along with this? This is important, right? I'm going to show you guys where this all comes from. I'm just introducing it first, and then we'll walk through an example here in a second. Okay, but volume is a measure of 3-dimensional space. Okay. Oh, sorry, I forgot. In the middle here, liters and milliliters are the units that we're going to report this. Okay. Typically, it's going to be liters that we say, but often the scale that we work on things in this lab or in chemistry is in milliliters there. What does it mean to be a milli of something? A milliliter. Yeah.
1,000.
Right, 1,000th of something, right? If I have 1 liter and I divide that by 1,000, right? That's what a milliliter is, right? So I'm just drawing information from here, right? 10 to the minus 3, right? 1,000th of something. Good? All right. Like I said, don't worry, we've got practice where I'm just going. Okay. Where did I do all my stuff? Oh, okay. All right. So volume, the amount of space occupied by something. Space is 3-dimensional. We have cubic units, right? If we have a cube, that the length is 1 centimeter. What volume would it occupy, right? Length times width times height. 1 centimeter times 1 centimeter times 1 centimeter, right? So let's take a look at this here real quick, right? So if I have a cube and the length is 1 centimeter, right? So length is 1 centimeter, this is 1 centimeter, that's 1 centimeter. What volume would it occupy? Okay. So I have length, oh, let me back up here for just a second, right? So we know for volume, we have length times width, right, times height, and that's going to equal our volume, right? Everybody comfortable with this? Right, we have 3 dimensions, length, width, height. If we have a cube, it implies that length is equal to width is equal to height. All right, that's the definition of a cube, right? Everybody good so far? Okay. So what does that mean? If I have 1 centimeter as length, right, times 1 centimeter as width, times 1 centimeter as height, right? What is my answer going to be for volume? Well, 1 times 1 times 1 is 1. But remember, we're not just multiplying the numbers, what are we also multiplying together? The units. Good? Right? So what's centimeter times centimeter times centimeter? Centimeters cubed. You guys got it. Everybody with me on that? This is important, okay? Area works the same way, except we only have 2 dimensions, right? Length times width. So if we have a square whose side is 1 centimeter, right? We do 1 centimeter times 1 centimeter, and we report things like 1 centimeter squared. Good? All right. Now, one of the first things that we'll learn about is density. Okay? So density is a physical property of a substance. Remember last time we talked about physical properties. What was the definition for a physical property? Something that we can measure that doesn't change the composition, right? Doesn't change whatever it is that we're looking at, right? So we can measure the density of something fairly easily, right? It has units derived from mass and volume. Okay, so volume is what we're just talking about, typically units of liters or milliliters. What are the SI units for mass that we just talked about a couple slides ago? Kilograms, right, or grams. So whenever you see something reported, right, in units of mass per volume, okay, this is what density is going to be. Or what they're trying to tell you is the density of that substance, okay? So if we have a unit of mass over volume, they're talking about the density of this. Okay? The DMV, density, mass, volume, right? The most common units that we see are grams per milliliter, although if you go to your friend Google, they might refer to you kilograms per cubic meter, okay? I think engineers prefer that, or material scientists prefer kilograms per cubic meter. I'm not quite 100% sure why they're going with that, but that might just come from the SI units itself there, okay? That's okay. So grams per milliliter or kilograms per cubic meter. We're just talking about density with that. Okay, who cares? Density of air, water, blah, 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 all this kind of stuff here. Now, why am I telling you guys all this stuff? So let's say that you walk into the lab today or whenever it is, and there's a chunk of metal that's just sitting on the table, okay? How could we identify what that metal is? Well, later on, we're going to learn a couple of reactions. So we could test that, we could react that, right? But one of the things that we do typically in lab is give you an unknown metal and say identify what that metal is using the density, okay? Can you measure the mass of something without changing it? Absolutely. Can you measure the volume of something without changing it? Absolutely, right? And so we can measure the density, and we can match up if we have a list of densities what that metal might be or something like that, okay? Not too bad, right? Question, or excuse me, not question yet. Quick comment here. So here's another bit of information for you guys to, let's say, memorize, okay? For our purposes, unless it's explicitly stated otherwise, we will assume that the density of water is going to be 1 gram per milliliter, okay? So for our purposes, unless it's stated otherwise, the density of water will be 1 gram per milliliter. Now, why is that useful for us? Well, we're going to have to do some conversions with this. Let's think here for just a second, though. How can we use our density equation here? What does this equation relate? It relates 3 things for us, right? It relates density, mass, and volume. Got it? Let me ask you a question. If I give you the density of something, and I give you the mass of something, could you calculate its volume? Sure. If I give you the volume of something and its density, could you calculate the mass of it? Sure. If I give you the mass and the volume, could you guys calculate density? Sure. Do you guys get what I mean with this? I have an equation, or I've given you an equation with 3 variables. How much information do you guys need? 2 of those, and then you can solve the rest of it. You guys good? This is good. That's all the math you guys have to do for this class. So if you're struggling with the math in here, and believe me, I did too, right? I'm not trying to look down on anybody, right? But start to simplify what these equations do and how many variables there are, and start to think about where can I get mass from? Oh, it's a unit of grams. Let me look for information about grams in here in some way. Okay? So kind of back out and simplify this stuff, and maybe it won't get that scary. Okay? But rearranging equations, calculating for missing variables, that's all we're going to be doing, right? All right. Man, finally I get to stop talking. Do you know how hard it is to be a professor? I've had to talk to you guys now for 40 minutes almost. Oh, I'm done for the week. All right, you guys do some more. See if you guys can figure out some of these answers here, right? So work with your neighbor, work with whoever you want to, see what you guys can come up with, all right? So let me do a little bit of thoughts here for a second. What is its density in grams per milliliter? Okay. So let's say, what is the density in grams per milliliter? So see what you guys come up with. I'm just seeing if you guys can do this. The screen's blurry. Okay. What's up? Yeah, for now, yeah. So while we're in class, use whatever you want to, yeah. No worries. Yep, so we have mass over volume, right? Correct, yeah. You can use your phone. Yeah, like when we're in class, use whatever you want. It's only on the exam where I'm strict about it. Okay, you have to use it. Remember, a kilogram is about 2.2 pounds, right? A gram is a smaller unit than that, right? So I'm just trying to, like, maybe contextualize something else, yeah. It's kind of tricky at the beginning to remember which one is bigger and smaller, that kind of stuff. Favorite part of class, where you don't look at your work and you guys do this. Oh, man, they don't know what no, you're all good. You guys are all good. Yeah, right, so, let's see if we can get right? So now to be fair, how else does it sound? If you just did this math right here, you would still give me a measurement of density, but it's not in the units that we typically expect it to be, right? So that's why I had to make that addendum there. If you did that, if on the exam, you just did what you did there, then it would be fine, because, well, I didn't specify the units I wanted, right? Don't worry, I'm not gonna be that super like. There's always going to be units, yeah, right? So it looks like you convert things to grams, so that you have milliliters. And so what are units? Over in the corner, how's it looking? Okay. You're telling me there's 1,000 kilograms. Does that make sense? Well, I mean, no, right, it should be the opposite, right? There's 1,000 grams per kilogram. Yeah, so be careful doing that, right? Okay. Yeah, follow your units through and see what you're trying to calculate with that, right? I'll show you guys in just a minute. How's it looking? Still working on it, all right? How's it looking over here? Good. Awesome. Okay. I see your work here. How did you come, oh, did you convert this into grams? What did you do? Why did you do it like that? Just out of curiosity, I'm not saying you're right or wrong, I'm just trying to follow your math. Right, so kilo is basically the prefix for 1,000, right? So you need 1,000 grams to make it 1,000. So my advice is, it looks like you didn't write, but my advice is always just to write everything out, right? And the reason why is because if you're like me, I make mistakes constantly, right? Then if I'm checking myself, I'm like, oh, what did I do in my calculator? You know, that kind of thing there.
Still in the denominator.
Well, that's for pounds, right? Well, you have to convert grams into, or kilograms into grams, right? So you know, if we were dealing with pounds and all that kind of stuff, that'd be fine, but we're doing a different conversion. So take a look at the notes when we have how many kilograms are in a gram, you know, those different exponents and that kind of thing, okay? Well, it depends on what you're trying to convert, right? So for this question, it's saying, okay, give it to you in kilograms, you convert it to so this is the one that you're have to worry about. But you don't need to do anything, but that's still part of your answer at the end. Does that make sense? So only worry about this one. No, it's a good question. You asked.
You write it like random millimeters, or you write it like that?
Either way, I know what you're doing. I mean, for usually I write it like that for my final product, but I see it as my own answer. If I'm still doing the math, you'll see me like but it just depends on what part of your math I'm working on. At the end, that's it.
Okay, and then, what is that right?
You guys all righty. So, as I shared with you guys earlier there, I'm not, you know, just trying to say something to make you guys feel comfortable, whatever it is. Like, math really isn't my strong suit, okay? I'll go ahead and tell you, I'm probably gonna make maybe some math mistakes as we go through this class. I'm sorry to burst your bubble about my perfection, okay? I know that you guys held me in high standards there. I make a mistake, okay? So, I'm just telling you that way I work things out is because I am very deliberate when I write things down, say I have to write everything on paper. This is how I catch my mistakes. Okay, so when you see me writing a lot of things out, it's not just for show for you guys, that's part of it for sure, right? But I write things out because I catch 99% of my mistakes when I'm like, hey, wait a minute, I think I flipped this, or somewhere I missed a multiplication or something like that, okay? Write your stuff out on paper. I've got a better deal for you. I will give you guys all the paper you will need to work out things in this class. How's that sound? Good? Because I have access to the printer paper. Which you guys paid for with your tuition, right? So if you guys need paper, don't worry, I got you covered. And if you guys need a pen, I'll even give you an extra pen. What I'm saying is don't worry about ink, don't worry about paper. What's more important, saving a couple calories, saving a couple pens, or getting an A in this class because you wrote out all your work? I would say an A in this class, huh? And if you guys are like, well, Dr. H, calories are expensive, I got a bag of Jolly Ranchers in my office. So I'll give you all the sugar that you need too. Sound good? So I got everything covered, so you guys are gonna write out all your work for me, yes? Yes, why else would you guys write out all your work for me? Because I don't give too many multiple choice questions on exams, right? Why? They're not good ways of asking questions, right? It's not a good assessment method for students to understand it. I'm gonna give you guys a lot of word problems that you guys are gonna have to do a lot of math to solve it, right? So if you guys take 10 steps and you write out all 10 of your steps in, for the math that you did, and you just happen to switch a plus and a minus at the end, what do you think will happen? Do you get the whole thing wrong? Or will I give you 9 out of the 10 points? 9 out of the 10 points probably, right? So show me your work on quizzes and exams. Got it? Show me your work, and then I can find partial credit and give you guys the credit that you guys earned. Does that sound fair too? So get in the habits of doing this now. But I don't give partial credit if you guys don't have units with stuff. Okay? Get in the habit of writing units down. Sound fair though? Cool. So free Jolly Ranchers and paper. That's my bribe for you guys. All right. So I need to get an answer in grams. Okay? Well, I'm giving units of kilograms here. So I know I'm going to have to do a conversion, right? I need units of milliliters. Well, I've already got units of milliliters there. So what do I need to do? Do I need to do anything with the milliliters? No. But I need to do what? Convert kilograms into grams. Got it? So that's what I will write out. I have 0.002234 kilograms of something. Okay? And I need to convert that into grams of something. Here's how I work. Okay? I am now doing unit conversions. What they call this in the book, and it sounds really fancy, so you guys can use it, they call it dimensional analysis. Okay? Which kind of makes sense. We're just looking at different dimensions of things, right? The units that go with it. So if you go to YouTube and type in dimensional analysis, it'll come up with a bunch of videos that talk about stuff like this. Okay? And I think I have some links for you guys in the modules already. Okay? I need to convert kilograms into grams, looking at just the units themselves. Okay? If I am starting in kilograms, my kilograms go on the bottom, because those units are going to cancel out. You guys with me on this? You guys might have been taught like the train tracks method or something like this. There's different terms for it that different math teachers teach you. Okay? Something on the top cancels out with something on the bottom. That's all I'm saying. You guys with me on this? Okay? So if I cancel out my kilograms, and I need to get to units of grams here at the end, I better put grams up on the top here. Good? Everybody with me? Okay. Now I need to put in my conversion factor. Okay, conversion factor is how I go from kilograms to grams, or grams back into kilograms. How much of one thing is in the other? That's what a conversion factor is. How many tires are on your car? 4, right? So what's the conversion factor between tires and car? For every 1 car, I have 4 tires. You guys with me on this? I'd drive a motorcycle, Dr. H. Okay, all right, we get the point. Okay. You guys with me on this? We're just saying how much of something makes up the bigger part here, okay? So here's how I typically work. For every 1 kilogram, I have 1,000 grams. You guys with me on that? Kilogram is bigger than a gram is. I'm looking at that table that we had previously there. Okay? Good. And if I do this math in my head, I didn't bring my notes with me, so I'm going on the fly here. That means for every 0.002234 kilograms, I have 2.234 grams. Good? all right? An alternate way, 0.002234. Some of you guys might have done this. Right, for every 1 gram, I have 10 to the minus 3 kilograms. Okay? Is that going to get me the same answer? The answer is yes, right? Plug it into your calculator. No, you don't have to believe me. I hope it's the right thing. I'm getting recorded. Right? Is that going to get you the same thing? What is the difference between these? Okay? Well, the difference is what? On top, I am saying for every 1,000 grams, I have 1 kilogram. Here I have for every 1 gram, I have a 1,000th of a kilogram. What does 10 to the negative 3 mean? Right? 10 to the negative 3, right? 0.001, right? Tens, hundreds, thousandths. You guys with me on that one? Which ways of these methods, using the decimals, using to the negative 3, which one of these is the correct way of doing it? All of them. Got it? Do I care which way you guys do it on the exam? I do, because I want you guys to get the right answer. Do I care which of these ways you guys do it? Absolutely not. How am I going to know which way you guys did it, though? Because you wrote it out. You guys with me on that one? So show me your work. Keep your units with it and think and double check when you're doing this dimensional analysis. Is it 1,000 kilograms or 1,000th of a kilogram? Right? You know, these kind of questions. Talk your way through it. Be a weirdo like me and you'll see me muttering to myself. Okay? It's fine. Don't worry about it. Okay? Good though? Everybody with me on that? So now we have, let me just give us some space here. Right? So now we have our answer. Now we have our answer in grams. Okay? We have that many grams, and so how do I finish this up? I'm asking for density. Density is always mass per volume. Okay? So to finish this up, 2.130 milliliters, right? And my answer, somebody give me that number, please. I don't have the answers in front of me. 1.049. 1.049, okay? What are my units? Grams over milliliters, okay? I have grams on top, I have milliliters on bottom. Nothing cancels out here, right? You guys with me what I mean there with canceling out? Right, just grams over milliliters. Good? What's up?
Is there a certain number of sig figs you want to use?
Ah, the dreaded sig fig questions. Okay, so, here's my view on sig figs, okay? I'll go ahead and first I'll pander to the other scientists who might watch it. Don't worry, no one's gonna watch this. And my mom doesn't even watch this stuff, so it's okay. Anyway, so sig figs are extremely important. There is a reason why we spend some time talking about significant figures, and especially when you're dealing with measurements and doing all this kind of stuff. Okay, I don't want to dismiss that side of it. For those of you guys who are going on in your careers as scientists, when you guys are starting to do your own research and all these kind of things, and you're generating data, sig figs, extremely important. Okay. I'm about to publish another paper here where I'm going through and double checking like all the significant figures that I'm about to report. Okay, because other scientists will look at this stuff. Is it important? Yes. Will they reject a paper for incorrect significant figures? Absolutely they will, right? So it's very important. Are you guys scientists yet? We're working towards it. Are you guys about to publish a paper in general chemistry? Don't say no, you never know what's gonna happen. But do you guys get the point that I'm making? What I'm trying to tell you is for my class, right, while you guys are in here, do I care all that much about sig figs? No. What do I care about? Can you guys do the math? Can you guys set it up properly? Can you guys convert the units properly? Okay? Now, when you're going to, for those of you guys who have lab with Dr. Tong, and I think even Dr. Fries, they're very much sticklers on sig figs in there. Okay? But on this exam, I'd rather have you guys understand what density is and how to calculate rather than, oh geez, is it 1 or 3 sig figs or all that kind of stuff. I'm not going to count off for that on an exam or a quiz or any of that kind of thing. Does that seem fair? So keep it simple. I don't need you guys to report 10 decimal places for me, right? If you guys are calculating something out, just put your answer down, you know, and put it to a reasonable scale, and then I'll be able to follow along with you guys on that. That seem good? You guys get the point though? Sig fig's important in here right now, not so much. Okay, cool, good question. Anything else at the moment? All right. Find the volume in milliliters of an object that has a density of that and a mass of that. Okay, so what are we dealing with here? So I am given a value of mass, right? So M equals 30.0 kilograms, okay? Density is 10.2 grams per milliliter is what I'm given. And I'm asked to figure out volume, okay? So, until we all get comfortable, I'm gonna keep pointing out the obvious sometimes. And even after that I will. What did I do first when I approach a problem like this? The first thing I did is what?
Wrote out your given information.
I read it, I wrote out my given information. Why? Because now I've simplified it, right? I have three things. I need to figure out volume. I'm given mass and I'm given density. Do we have an equation that relates mass and density and volume? Absolutely we do. You guys with me on that? So let's write out that equation. All right, so keep changing colors here. Mass, right, over volume, right? Whoops, over volume, right? Equals density. There it is. Good. Can I just plug the stuff into that equation there and solve? Let's see, volume in milliliters, but I'm given units of what? Whoops, I'm sorry, I did a little typo there. Right? I'm given units of what? Liters. So I'm gonna have to do at least one conversion, right? Liters into milliliters. What else? I'm given a mass of kilograms, okay? But here I have units of grams. So I need to do two different conversions here. Got it? Kilograms and grams, milliliters and liters. So let's get this all set up here then, okay? If you guys haven't worked through it, I'm just giving myself some space here, so let's see here. So 30.0 kilograms, right? I need to convert this into grams, kilograms on the bottom, grams on top. Looks familiar, huh? Okay. Good. So what do we have? 30000, right? So 30,000 grams. Let's do this here. Let's convert liters, right, into milliliters here. I'm gonna write this down. I want you guys to follow along with me, okay? So you guys see how I set up my conversion here for liters to milliliters. Liters is in the bottom of what the information I gave you, correct? I need to get it into grams per milliliter. So if I'm trying to convert this unit, it's gonna cancel out with this up here. You guys with me on that? I'm gonna convert into milliliters and I'm end up with units of grams per milliliter. Everybody following along with that? Okay. Okay. What's the relationship between liter and milliliter? What can we say about that? For every 1 liter we have 1,000 milliliters. For every 1 milliliter we have a 1,000th of a liter. Right? Either way you guys want to do this. I prefer to always do that, right? Just how I remember it a little bit easier, okay? Give myself some space. All right, what's my answer here? 10.2 divided by 1,000 is 0.00102? Did I add too many in there?
Point zero.
0.0102, okay, yep, thank you. Cool. Is everything in units of grams now? Yep, is everything in units of milliliters? Yep. So can we go ahead and do what we need to do? Yep. Okay. See, density, right, equals mass over volume. What are we trying to solve for? Volume. So how can I rearrange this equation to get volume out of there? Yeah.
Mass divided by density.
Mass divided by density. Everybody with me on this? Right, if I rearrange, volume is equal to mass over density. Everybody good on that? Do we have units of mass? 30,000. Do we have units of density? Grams per milliliter, right? Good. I want to give you guys a second to write this down, and then I'll talk about one last thing. Just running out of space. Everybody good before I hit the delete here? So volume equals mass over density. I am right now in units of grams, right? We had 30,000 grams. What's my units of density that I had? Grams over milliliters. Here's my units, right? Grams over milliliters. Everybody following along with this? This is the tricky part. What will my units be in my answer? Right? Does grams gonna cancel out with grams? Yeah. So if we just simplify this, we're left with 1 over milliliters. And what happens with 1 over milliliters? It just turns into milliliters. Ooh. Now if you're just heard me say this and you're like, I have no idea what he's talking about, that's okay. What I'm doing is I'm proving to you that we end up in the correct units for the math that we're doing, okay? Anytime you do 1 over whatever, right, we just take the reciprocal of it, right? That's all it is. So we just flip everything over. You guys heard that term before, reciprocal and flipping things, that kind of stuff? Okay? That seem good though? All right, so I think this is good. What time does class actually start? 11? Oh, it is 11:50. Oh, okay, cool. So perfect. So this is a good place to stop. We're going to continue on Friday there. Don't forget about the research stuff tonight and lab and all that kind of stuff that's going on too. I will see you guys next time.